Hello everyone. Our project is Sign Language Translator using Hand Symbol Recognition. We are a team of three, Harshita, Arjun and Ajay. Our guide is Professor Purvi Datta, Electronics and Communication Department, PES University. Problem statement. Deaf people find it difficult to communicate with the outside world and human sign language interpreters are not always available on short notices. The motivation of our project is to create a translator that allows speech impaired and non-speech impaired people to communicate.
Block diagram. Training data is captured using OpenCV and necessary pre-processing techniques such as YCBCR conversion, Gaussian blur and max contour are applied. The horizontal and vertical gradients are calculating using Sobel filter. The histogram is normalized and all this combined histogram is fed into SVM. In a similar way, applying the pre-processing technique, the testing images are fed into the SVM model. The first step is capturing dataset. The dataset is captured such that the variation and accuracy is balanced. Our next step is pre-processing. The raw image is in RGB mode originally, which is not efficient for image processing. The intensity of individual color change if the brightness is changed. This problem is overcome by converting image to YCBCR color space. Our next step is applying Gaussian filter. The use of Gaussian filter reduces image noise. It is also used to reduce chromatic aberration, that is the colored fringes at the edges of a high contrast picture. Our next step is max contour. Contours are useful for object tracking and recognition, shape analysis, determining the size of object of interest and detecting objects.
After pre-processing, features have to be extracted from the images. Horizontal gradient of an image is how much the pixel values change in the x direction, and vertical gradient is how much the pixel values change in the y direction. To calculate the gradient images, we will be using Sobel filter. The function cv2.sobel has parameters for dx and dy, which has to be set to 1 and 0 for Sobel x image and interchanging the parameter values to get Sobel y image. Resulting Sobel x image has vertical edges highlighted and Sobel y image has horizontal edges highlighted. The function cv2.card2polar is used to find magnitude and angle from the two gradient images. The images obtained are divided into 8x8 pixels, which leaves us with 64 magnitude and angle values. These values have to be grouped into a 9-bin histogram. The values are normalized using Hellinger kernel. There are 9 bins which correspond to the range of angles 0 to 20, 20 to 40 and so on, with the last bin ranging between 160 to 180. The magnitude values are added in their corresponding bin, which is known from angle values, and the histogram obtained is a feature vector of size 9 which has to be fed to the SVM model.
A SVM or support vector machine is a supervised machine learning model that uses classification algorithms for n-group classification problems. The SVM plots each data item as a point in n-dimensional space where n is the number of features which was obtained from normalized hop in the previous section. Then it performs classification by finding the hyperplane, also called decision boundary, that differentiates these classes very well. SVC and RBF kernel. Since the input data to SVM is not linearly separable, we use a nonlinear SVM which uses kernel function to convert nonlinearly separable input space into linearly separable feature space. We use nonlinear SVM of type SVC and kernel type RBF. Overall procedure. We have represented our project procedure so far in the form of block diagram, from creating the dataset to predicting the output. Our next problem is to present this to a common user to use our project. Flask. We use Flask, a microweb framework, for developing our website. The Python Flask and ML model is hosted on the server side, and the front end is the interface with which a user interacts with the project. We have used HTML and CSS to design the front end of our project. Website interface. This is the first page of our website, and this is the second page of our website.